question that that looks a lot like one you've seen before. We're back to the area of a cone, or the volume of a cone rather, but this time they've given us the radius. We've said the radius is equal to, I'm going to look at this example and make it up, we'll say 3 centimeters. But they haven't given us the height. They haven't given us the height, which normally we need, because remember, the way we find this is we find the area of this base circle, which is just going to be pi r squared, and r is 3, and we multiply that by the height. Right? And that gives us this. Pi r squared times height, and then because it's a cone, because it comes to a point, it gets divided by 3. And that equation would get us there. The problem is that we don't have the height. We have to find the height. And what they've given us is the slant height. So in this case, I'm going to say, let's say they gave it to us as 5 centimeters. So the first thing we have to do in a question like this is find the height. And if we look, we actually get a triangle here. So I'm going to ignore the rest of the question for now. All we're interested in is finding this height. We want to know that. But what we know is this side is 5 centimeters, and this base 3 centimeters, because that's the radius of the circle, and that's the slant height they gave us. And what we can use is the Pythagorean theorem. So remember that for any little triangle like this, if we build a square off this side, and a square off this side, those two squares can be put together, and they will perfectly make a square that comes off the third side, off the biggest side. So the biggest side is made up of the two small sides if we build squares off them. And what that means in this case, and we sometimes write that with the equation a squared plus b squared equals c squared. If we square the two small sides, we get the big side. In this case, we know the big side. So we're not going to be adding to get together to get the big side. We're going to have to be subtracting because we want to get one of the small sides. So here, we're going to say the big side, 5 centimeters squared. And we're going to subtract one of the small sides, in this case, 3 centimeters squared. And that's going to be the side we don't know, h squared. And we can do this just in one step in our calculator, but it's not that difficult here. This would be 25 centimeters squared minus 9 centimeters squared. That's going to equal the square of this height that we don't know. 25 minus 9 is 16. So 16 centimeters squared. And once we've done that, we don't know how big the height is. We know this. We know the square of it. And to go from the square to just one side, we can say that the height would be the square root of 16. And that's easily done. The square root of 16 is just 4. So the height must be 4 centimeters. And we can go back to our original question now, back to this cone, and we can fill this height in now that we know it. It's 4 centimeters. And now this is practically simple. Now it's an equation you know. We're just going to use this. Volume equals pi r squared h divided by 3. So we would go down here, and we would say the volume is equal to the area of that circle, the base, which is pi times the radius squared, which in this case is 3 centimeters squared, times the height, which is 4 centimeters. And because it's a cone, because it's a shape that comes to a point, we divide it by 3. And now I can just do that right on my calculator. That's precisely what I'm going to do. Pi times 3 squared times 4 divided by 3. And I get 37.69. So I'm just going to say, since we have no decimals in the question, I'm going to round that to 38 and say this is 38 centimeters. And of course, that's going to be centimeters cubed because it's a three-dimensional shape, and a three-dimensional shape always needs to have a three-dimensional unit. In this case, cubic centimeters.